So just a short update about the progress on my computer space electronics boards. So what you can see here are the three boards that are quite familiar. First and foremost is here the memory sound board in the front with its famous shaped diode placements, or nothing special here. What is actually a little bit different than what you usually know about computer space is this backplane board. The idea behind was that actually the normal or usual backplane is hand wired and also uses some very outdated and special connector types that are actually hard to source. And also because this is a replica, so I don't have any of the original parts, or anything that I need to implement is somehow need to be sourced separately. So when it comes to power supply, as you know, computer space requires 5 volt DC, 12 volt DC, and actually my immediate thought was that PC power supplies are fit in very well, because you see here a very cheap one, nothing special here, 20 bucks on Amazon. So this is everything basically that you need to power the computer space boards. And yeah, so the backplane board has here in the center the standard Molex connector, 24 pins, as is kind of standardized. So any of these type of power supplies will just fit in this plug. And it already comes with 5 and 12 volts, as already mentioned, and also has some nice additional goodies, like for example, that you can attach a remote switch, which has then control over the power supply. I will show you later on. And also have kind of a standby power supply, 5 volts, which means even now when everything is powered off, for maintenance or investigation topics, you can have here 5 volts to power some analysis tools or stuff like that, while the rest of the board is completely powered off. So besides of the power, and by the way, the 12 volts power supply that the computer space needs are actually for the lighting of the bulbs, either in the control panel or also this tiny marquee thing or description thing that is in the bezel of the monitor. So those are taking the 12 volts, and also the soundboard is actually using to produce the sound. It requires the 12 volts. What else? And also the coin counter that you see here is running on 12 volts. This is valid for the original one in the past and is still valid as today. So we have here a mechanical counter which still uses this 12 volts. So so much about the power supply thing. The other connectors, of course, are interesting, I hope. So as already mentioned, so we have here two things in the area of controlling the power. So we have one manual switch, and we have a connector for an external switch, and we have a power indicator LED. So the story is that the original port has a door open switch, which actually disconnects the power as soon as the door gets opened for security reasons, for the operators to not get harmed. So this is also supported here. The external switch has just to be connected here on this 2-pin connector. And actually the thing is, if you go for maintenance or troubleshooting or whatever, while the door is open, you want to overrule the door switch, and this is why there's a manual switch to override the door connector, the door switch. So said that, with this switch we can now power on the board if we want, but before we do that, let's continue with other connectors here. So what we have here are power supplies for 12 volt and 5 volts. The intention is to power a cooling van. So actually have connected here via this black and red colored wire a 12 volt fan, so it goes down here, so you see the thing here. So it's actually connected to the 12 volts output. But of course there are also 5 volt cooling fans, and there's a second connector that provides 5 volt just in case that a different one should be used. Then what else do we have in terms of connectivity? Then we have here a 2-pin connector where the coin counter gets connected. This gray cable here is going to a mechanical counter. And then we have, that's the one here. Then we have here a 3-pin connector, which is typically for the connectivity to the monitor. And they are labeled just exactly like the colors are in the original cabinet. So it, in theory, would be possible to also drive original cathode tube monitor, which can easily be connected there. And then we have an RCR connector, which is basically using the very same signals here. So the one on the top is the video signal, then we have 2 lines for the audio signal. I know the board is mono sound only, but if, like I have actually this LCD just as a testing device, which has 15-inch diagonal and also has a 4:3 aspect ratio. So it has actually exactly those connectors and also has 2 speakers. And so by connecting both speakers to the one sound, mono sound, both speakers will be driven. And the last thing here in the back is a barrel connector for 12 volt DC. Actually, what is quite nice is that this PC power supply comes with 2 different 12 volt rails that are completely disconnected. So one rail I'm actually using to power everything else in the board, especially the soundboard. And the other rail is exclusively here connected here to this connector. And as you can see, there's a power cable, 12 volts, going to the back, and it drives also the power for the monitor. So the monitor is completely and exclusively connected here. And a nice side effect of that is also that this one switch, either the door switch or this manual switch, it's not just powering the board itself, but it also immediately powers the monitor in the back. So said that, let's give it a try and see how things are working actually. I put on the manual switch. The beep signal that you have heard is actually beneath the control panel. We have this coin selector or coin mechanic. So it gives a short peep to indicate that it's powered and okay. Don't get confused with this weird color scheme. I will change it later on to the authentic one. And of course we need to have a coin here. As you can see, the power has come up on the monitor while powering the boards. And what else? Yeah, so we already have a video signal that is quite proper. And let's see how the coin counter will enhance once I put on here the coin. Let's put it in and let's see. Yep, didn't work, did it? Most likely. I have a bad connection here. Let's try it again. Let's see. Oh, it advances. Yeah. So count counter advances. We have no actual credit on the board. And if I push the start button here, we also hear that we already have a sound. So there are still a couple of issues that I need to track down. So the UFOs seem to be somehow weird on the left side. It's a little bit squeezed. There also seems to be an issue with the thrust of the spaceship in a certain angle. It doesn't accelerate as expected. What else? Also, once I have a credit, it will not go away. So there's also something on the sync port I have to track down. But actually, I'm quite happy with the progress. It's very promising, and I'm very confident from this point on that I can track down each and every remaining issue. Actually, there's still just a fan. It's dropped. I actually still work with this workaround, this potentiometer, to have a stable signal on the video board. It works quite reliable, so I think I make this temporary workaround a permanent one, as it seems to work anyway. Good, so much about the progress on my electronics board.